In the summer of 2022, the James Webb Space Telescope began its mission. Around 1.4 million kilometers from Earth, the Hubble successor will search for the oldest light signals in space. It was envisioned that Webb would peer into the dawn of space, but within hours of the first images being released, it was clear that Webb was not seeing the beginnings of the cosmos. Rather, this telescope is showing images that indicate that our cosmological view of the world has been wrong up until now. With all the excitement, one discovery has almost been forgotten. In March 2022, when no one expected a grand discovery anymore, the old Hubble telescope shocked scientists by imaging a star that came to be known as Earendel. Earendel was and is the oldest single star ever glimpsed by humans. Find out what Hubble, Webb, and the Star of the Dawn are all about in this video. Before we share the exciting facts with you, we would like to ask you to leave us a comment at the end of the video. Tell us what you think about the video and the latest findings in astronomy. In the future, we will reward our subscribers' contributions with a heart. We'll also pin your important post to the top so everyone can read it first. So make sure you subscribe, like the video, and mention both at the beginning of your comment. We're looking forward to hearing from you. And here we go with Earendel, the oldest star ever seen by man. An unexpected discovery. The whole world was already squinting at the imminent start of the Webb mission when astronomer Brian Welch of Johns Hopkins University announced the unbelievable. In an image shot by the ancient Hubble Space Telescope, researchers were able to identify the oldest single star ever discovered. The object was initially given the somewhat technical-sounding name WHL 0137 LS. But this wonder became known worldwide a little later as Earendel. Earendel comes from Old English and means morning star, or also rising light. If you know the novels of the English writer J.R.R. Tolkien, the name probably sounds very familiar to you as well. There, Earendel is the morning and evening star, whose light gives immortality to the elves. So this celestial body was given a truly mystical name, and somehow it fits. The age of Earendel could be determined to about 12.9 billion years. Thus, already in March 2022, it was clear that this star existed about 900 billion years after the Big Bang. At that time, researchers still assumed that Earendel was one of the first individual stars that had been loosely distributed in space after the Dark Ages. The ancient light became visible only by a phenomenon that astronomers call the gravitational lensing effect. The gravitational forces of the upstream galaxy cluster WHL 0137-08 amplified Earendel's light so much that the single star became visible despite its enormous distance. This effect can be compared to running a curved magnifying glass over a map. Individual sections are enormously magnified, while the surrounding sections bulge. The galaxy at whose edge Earendel was discovered was dubbed the Sunrise Arc. Still, researchers assumed they had approached cosmic dawn with this discovery. But then Webb came along and everything changed. Webb clears up old ideas. If you follow our channel regularly, or are just a fan of astronomy in general, you already know that the cosmic worldview has been under scrutiny since Webb's first image. James Webb's deep-field image revealed so many ancient galaxies that the Big Bang is currently looking increasingly unlikely. If it did exist, it almost certainly did not take place 13.8 billion years ago. James Webb did not only show us galaxies, which should not exist according to the cosmological worldview, but also provided us with a new picture of Earendel. On the deep field image, Earendel can be seen as a tiny little point of light. You can also see the ring of light in the image, which researchers call the Sunrise Arc. The brightly shining star in the image is much younger than Earendel. You can tell by the blue-white light. In this image, the brightest objects are the youngest and closest, while the red, dark, and rather fuzzy light signals come from the oldest objects in the cosmos. Thanks to this image, researchers were able to get an even better picture of the dawn star. Earendel probably had a mass of about 50 to 100 suns, and thus belonged to the blue giant stars. That we use the past tense here is correct, because Earendel very likely no longer exists today. The lifetime of the first big blue star giants was very probably less than 4 billion years. If the star still existed today, it would be about 28 billion light-years away from Earth due to the expansion of the universe, and even the James Webb Telescope would not be able to spot it there. Earendel's light therefore traveled 12.9 billion light-years until it hit the observation mirrors of the James Webb Telescope in the summer of 2022. In the light signals, researchers can find new clues about the star's nature thanks to the finest measurement techniques. Webb observed the star through 8 different filters, each of which can highlight different aspects in the light emissions. We now look at what scientists have concluded thanks to this new observation. Earendel's age. Astronomers determined the age based on the so-called redshift. On its long journey through space, the star's light is stretched, among other things, by the expansion of space. Due to the increasing wavelength, the light is shifted more strongly into the red range. The more the light of a galaxy or star is shifted into the red region, the more distant the objects are, and the further back in time is the moment when the light was emitted. The light of Earendel has a redshift of 6.2, which corresponds to an age of 12.9 billion years. Before the discovery of this exceptional star, researchers could only find stars with a redshift of 1 to 1.5, thanks to the gravitational lensing effect. As for the age, Webb was able to confirm the Hubble observation data obtained back in March. The unusual luminosity. Webb also revisited the luminosity determination and came to a clearer conclusion than Hubble had previously. According to the latest findings, Earendel was or is a Type B star with an effective surface temperature of 12,000 to 15,000 degrees Celsius. These are not the biggest and hottest stars in the cosmos, but they are close, and as you can see here, also much brighter and hotter than our Sun, which is a G category star. The brightness of this star could have exceeded our Sun by up to 1 million times. At that, the star must have possessed a mass that exceeded our Sun by a factor of 50. At the moment, however, astronomers cannot say with absolute certainty that Earendel is really a single star. The light could also have emitted from a binary star or from a multiple star system. The few stellar giants that still exist today usually have smaller companions or are multi-star systems. This is most likely because these large stars have an unusual gravitational pull and so like to attract other stars to their vicinity. Astronomers stumbled upon the fact that Earendel is 1 million times brighter than the Sun. Thus, this star bumps up against the Humphreys-Davidson limit, which is the empirical luminosity limit for all objects currently known in the cosmos. In short, one could also say Earendel is actually brighter than it should be, according to this scale. There are several explanations for this. If it turns out that Earendel really is a single star with millions of times the luminosity of the Sun, astronomers would have to reset the Humphreys-Davidson limit. Earendel was, according to ancient cosmic worldviews, a star of the first hour of the universe. This first generation of stars was previously referred to as Population 3. Until last summer, astronomers still assumed that the first stars in the cosmos were giants like Earendel. Through a process called primordial nucleosynthesis, the main chemical elements hydrogen and helium were formed. These two main elements formed the first generation of stars. These probably had only traces of metals, while stars of later generations show a higher metallicity. In order not to misunderstand this term, one must know, in astronomy, all elements, which follow in the periodic table after hydrogen and helium, are metals. Consequently, for the astronomer, not only gold is a metal, but also carbon. Astronomers believe that most of the stars of population 3 have died by now. The lifespan of the giants was very probably only a few 100 million years. The remaining remnants are faint and very difficult to observe, whereas, of course, researchers are hoping the new telescope will find many more very old stars. What will we learn in the future? As mentioned at the beginning of this article, the James Webb Telescope has already found several galaxies that far exceed Earendl's age. Since these galaxies have appeared in the night sky, many things have come under scrutiny. The universe is very likely much older than previously thought, or it began differently than astronomers and cosmologists previously imagined. Galaxies, which are 13.6 billion years old, have already existed 200 million years after the Big Bang, and with these light signals, it concerns clearly fixed and finished galaxies, which were unusually luminous and mass-rich. If one follows past models of the Big Bang, there should have been, at most, individual stars in this time, but no ready galaxies. Since astronomers have these new realizations, naturally, also Earendl moves into a new light. With an age of only 12.9 billion years, and measured by the variety of galaxies, Earendl's position as a star of the cosmic dawn is basically already outdated again. Unfortunately, we cannot currently detect individual stars in these now known oldest galaxies. However, it cannot be ruled out that future images of Webb and the gravitational lensing effect will lead to the discovery of still older individual stars that are still detectable today. Now, you tell us what you think of Earendl's discovery and the latest findings of the James Webb Telescope. Do you think Earendl really was a star of the first hours? Or do you agree that something can't be right about the previous assumptions about the age of the universe? We appreciate your opinion, and don't forget to mention your subscription, if you have one, and to like the video. We're glad you joined us today, and we'll see you next time.